There's a secret blueprint that dictates how your Wi-Fi, office network, and even the internet itself moves data around, but no one ever talks about it. It's called network topology, so let me explain. In this video, you'll learn what network topology is, how it works, and most importantly, why it matters to you. But first, hit that like button if you love nerdy tech stuff. And stick around till the end, because I have a quiz to test your knowledge. So let's start at the very beginning. What is network topology? Think of it as the architecture or design of a network. It determines how different devices like laptops, printers, and servers are connected to each other, and how data flows from one device to another. And there are a few main types of topologies, each with their own pros and cons. We'll cover the three main ones today. Now there are two types of network topologies, physical and logical. To make things easy, I'm going to ignore logical topologies since they can get complicated fast. Instead, I want to focus on physical topologies because they're easier to understand and visualize. And don't worry, I'll still make sure you walk away with the big picture. Physical topology refers to the actual arrangement of devices and the cables that connect them. It's like the street layout of a city. On a basic level, it answers questions like where are the computers and servers located? How are they connected? And what type of connections do they use? This physical layout is crucial because it directly affects the performance, reliability, and scalability of the network. One common physical topology you've probably seen before is the star topology. It's the most popular choice for home and office networks because it's simple to set up and manage. Here's how it works. All the devices like your laptop, printer, and phone connect directly to a central hub or switch. That central switch then acts as the central nervous system of the network, sending data to and from all the connected devices. It's much like how the sun sits at the center of our solar system with all the planets revolving around it. Just like how the planets would be lost without the sun, the same goes for the devices in a star topology. They depend on that central hub to send messages to each other. Let's take your home Wi-Fi, for example. Your wireless router acts as that central hub, allowing all your gadgets like phones, tablets, and laptops to connect and share information. Now here's the cool part. If one device like your printer breaks down or goes offline, it doesn't affect the rest of the network. The other devices can continue sending messages to the central hub, which will then forward them to their destination. That's a big advantage of the star topology. Each device has a direct connection to the hub, so it's relatively easy to add new devices to the network. You just plug them into the hub. However, there is a downside. If the central hub goes down, the entire network goes down with it. It's like if the sun suddenly went out, everything in the solar system would collapse into chaos. That's why it's important to have redundant connections or backups. In a home network, you could buy a second router and set it up to take over if the primary router fails. Businesses often use sophisticated setups with multiple routers or switches that work together to ensure that the network keeps running smoothly, even if one component fails. Another disadvantage of a star topology is that it requires a lot of cables to function. Every device needs a dedicated connection to the hub, which can get messy and expensive to manage, especially in large networks. Next up, let's talk about mesh topology. Unlike the star topology, where all devices connect to a central hub, mesh topology is more like a spiderweb where every node connects directly to two or more other nodes. It's much more complex than a star topology, but it offers some unique advantages. One major benefit of a mesh topology is that there is no single point of failure. If one device goes down, it doesn't bring the whole network crashing down. Data can simply take a different path to reach its destination. That makes mesh topology ideal for applications where high availability is critical, such as in telecommunications, industrial control systems, and even Bitcoin networks. Mesh topology also allows for dynamic routing, meaning that if a path between two nodes becomes blocked or congested, data can automatically reroute itself through available alternative paths. This self-healing capability ensures that communication remains uninterrupted, making mesh topology a popular choice for mission-critical applications. Of course, as you might expect, there are trade-offs. The biggest drawback of mesh topology is the cost. Connecting every node to multiple other nodes requires a lot of cables and hardware, which can add up quickly, especially in large networks. Additionally, managing a mesh topology can be complex since changes in the network require updates across multiple nodes. Moving on, let's explore hybrid topology. As the name suggests, hybrid topologies are a mix of different network designs, typically combining the features of other topologies like star and mesh to create a customized, more efficient network. For instance, consider a university campus network. The departments can each use a star topology with their computers and servers connected to a local switch. Then all the departmental switches can be linked together through a central backbone using a mesh topology. This hybrid approach ensures that communication within each department is fast and reliable, while also providing a robust connection between departments. Similarly, hospitals often use hybrid topologies to connect various medical devices. Critical devices like patient monitors and imaging equipment can be placed in a mesh topology to ensure high availability and redundancy. At the same time, less critical devices like office computers can be connected in a star topology to a departmental hub. This way, if there's an issue with a department hub, it doesn't affect the critical devices in the mesh portion of the network. It's like having the best of both worlds, combining the simplicity of a star topology with the reliability of a mesh topology. So now that we've covered the three main network topologies, let's compare them side by side to see how they stack up against each other. Consider factors like cost, reliability, and use cases to see which topology might be the best fit for different scenarios. While all three topologies have their unique benefits and drawbacks, they each shine in different areas. In terms of cost-effectiveness, a star topology is generally the most affordable, especially for small to medium-sized networks. Its simple design means fewer cables and less complex management, resulting in lower overall costs. On the other hand, if absolute reliability is paramount, then a mesh topology is hard to beat. With no single point of failure and automatic self-healing capabilities, mesh topology ensures that the network stays up and running no matter what. However, the increased cabling and management complexity of a mesh topology can make it quite expensive. Hybrid topologies offer a middle ground, allowing you to combine the benefits of different topologies based on your specific requirements. By mixing and matching elements of star and mesh topologies, you can create a customized network that meets your reliability and budget constraints. If you found this comparison helpful, remember to hit the like button for more insightful tech content. Alright, now let's finish up with a quick Q&A to see how much you've learned. Which topology do you think is the most popular? If you guessed star topology, you'd be right. Star topology is the go-to choice for most home and office networks due to its simplicity and affordability. But what about mesh topology? When is it the better option? You'd go for mesh topology when high availability and redundancy are essential. Think about mission-critical applications like telecommunications or industrial control systems where downtime is simply not an option. And finally, how does hybrid topology compare? Hybrid topology is the jack of all trades. By blending elements of other topologies, it offers flexibility and customization, making it suitable for a wide range of applications. Hopefully now you have a better understanding of network topologies and how they keep our digital world connected. Remember, whether you're dealing with a simple home network or a complex enterprise network, the choice of topology plays a crucial role in ensuring connectivity, reliability, and performance. Thanks for watching and happy networking!